All right, so this video will focus on 9.3. And as we go through it, we're going to first of all use as a warm-up, we're going to try to find the area of these various circles. And we already learned that the area of a circle is radius squared times pi. And if I look here, I have 3 and it says use 3.14. So now I'm going to change this. So for instance, if I have 9 pi, because I plug in 3 times 3, I'm going to now use the 3.14 as my number. As I told you, we'll use whatever it kind of tells me to use for this, because there's like 3 different ways to do it, right? The 22/7, and so on. So if I go through here and I just take 9 times 3.14, we'll all at least have the same answer of 28.26. And that's what we're doing here, units squared. So do the same thing for all these. Realize that number 4 you have to divide by 2 first, but try doing this. All right, so you should have 153 and 86 hundredths, 314, and then finally 50.24 centimeters squared. What we want to do today is find the surface area of a cylinder. And there's really a few things you have to know about the surface area of a cylinder, right? The first thing is, if I think about a cylinder, I have 3 major parts. I have my circle on the top, I have my circle on the bottom, and then if you would think about unrolling this can, right? And then I have this piece that would be like, imagine essentially unrolling it. That's what this piece of paper is representing. And so I'm basically unrolling this middle. So that's what the net of a cylinder will look like. Now we know how to figure out the area of each of these shapes, right? For a rectangle, it would be length times width. And for circles, it is radius squared times pi. So a few of these things are very easy. If I have a cylinder, it's drawn out like here, and I have this being 3, and this is 5. Well, I know that the top of this equals 3. So this thing here would equal 9 pi. And the top and bottom are the same, right? So this is also 9 pi. I know that this 5 here is the 5. But the part where it gets confusing is, how do I figure out this top piece? And really what it is it's unrolling this can, right? Figuring out, so again, unrolling it. And how do you figure out this distance if I unroll the can? Well, that's just your circumference of the circle. And circumference is, again, 2 times radius times pi. So if we look up here and the radius is 3, 2 of those would be 6. So I have 6 pi times 5. And 6 times 5 is 30. So I have 30 pi. This is 9 pi. And I basically have 3 different numbers I'm adding. The top, the bottom, and this piece here. And when I add up all 3 pieces, I'm going to have 48 pi units squared. And that's how you figure out the volume of a cylinder. So take a moment and try to figure out the nets of these things and determine what the actual surface area is for both of these. Now remember, it says round your answer to the nearest tenth. So the first one I do is I make my net like I showed over here. And I have my 2, so this would become 4 pi. And this is 4 pi. And then this is 4 pi across the top because it's 2 times 2, which is 4 across the top, times 7. So that's 28 pi, plus 4 is 32, plus another 4, which is 36 pi. If I take 36 times 3.14, I get approximately 113. Same thing here. It's the same exact steps. So now try doing this, where you make the net, and then you round to the nearest tenth. Pause the video and try it out. Great, and you should have something that looks like this. When you round it, it should be approximately 37.7 feet squared. It says round your answer to the nearest tenth. This one here is 100.5 feet squared. Again, you're rounding to the nearest tenth. So the key idea is, how do you make these nets? Remember, you need the base, so that's the top and the bottom. You need the height, and then you need the circumference across the top to determine this lateral surface. So here are a few more examples for you. Give this a try and find it to your nearest tenth. So you draw your net, and your answer will be 175.8 units or millimeters squared. A few more for you. Give these a try, pause the video, and your answers are right here. Example 2, it says how much paper is used on the label. So for this one, I don't want the top, I don't want the bottom. I just want to know what this label is equal to. So I'm going to get rid of these things up here, right? I just want this middle piece. And in order to do that, I'm going to go through here, and I'm just going to do my circumference of the top, which would be 1 plus 1, which is 2 pi. And then my height is 2. So this label is only 4 pi units squared. And that's all I have for this one, which is about 12.56. This one here, it says that you earn 1 penny. So I want to go through here and I want to try to figure out what this is equal to. So you find the surface area. In this case, I get 30 pi. For the last one, if I would add up everything and find out the surface area of it, I would have my 4 pi, which is a label, but then my top base and my bottom base, which we didn't factor in here, would have been 2 pi together. And that equals 6 pi. And it's saying, so if I have 30 pi equals x and 6 pi, I get 1 penny for. How much should I get for this x? And I can either cross multiply or just look at the scale factor. So this is getting 5 times larger, right? So make this 5 times larger as well. And I should get 0.05, so about 5 cents. And that's what I get here. Final one here is, imagine the height of the P of the can is doubled, right? What does that do to the amount of paper used, or does the amount of paper used in the label double? And the answer is yes, because you're double the height for that one. Does the recycling value double? And it's no, it's only the lateral surfaces are doubled. So the tops of the cans are not doubled. It's just the height. It's one measurement. So it will not be doubled. And that's